In this video, our purpose to understand how does the residue class field and map look like, and in the spatial case, the rational function fields. And for this purpose, let me remind the first example we considered for evaluation ring inside of the rational function, and which is determined by a given irreducible monic polynomial p of x. And we also claim that before showing that this valuation ring is also principal ideal, I mean, in general for the theory, we observe that this place, corresponding place, which is determined by p of x, indeed generated by p of x, or in other words, p of x is a prime element for p. And by using the representation of set in terms of p, we also defined the discrete valuation map, and we have also observed that v of p of x prime element is 1 when we denoted v p of x briefly by v. And now, in the rational function field, we want to understand, given a place, in this case, our first claim is that the residue class field indeed can be represented as the quotient ring k of x over the maximal ideal, which is generated by p of x. And to show this proof of the claim, let me consider a non-trivial K-linear map, or in general, you can also see that this is a ring homomorphism. Place K-linear and place also non-trivial ring homomorphism. And our first claim is that phi is onto, because if we are able to see that this map is onto, we will look for the kernel, and then we will apply the first isomorphism theorem. And in order to see that this phi is, which is defined as the evaluation of the polynomials at given place p, our claim is that for any function OPX, there exists a polynomial h of x such that its image is equal to zp. So for any element here, we can find a polynomial such that whose evaluation at p is equal to zp. And since we consider z from OPX, let me write it as a fraction of two polynomials u and v, where p of x is not divisible by p of x. Since p of x is irreducible, that means they are relatively prime. Their greatest common divisor is 1. And we can apply this identity to see that there exist two polynomials a and b, such that a of x times p of x, so the combination, polynomial combination of these two polynomials with coefficients a and b is 1. And here we multiply this equation by z, or let me write it again, u over v, And then here we will have cancellation. And then we consider the evaluation of this equality under the residue class map. And here, note that since the place is generated by the irreducible P of x, this multiplication lies in P. So the evaluation will be also P. And this shows us for every z in OP, there exists a pre-image of z of P in polynomial ring K of x. And we see that phi is onto. And kernel phi recall that we define this map, and the kernel of phi contains the polynomials which lies in P with respect to the identity of the residue class field. That means they are divisible by x, divisible by P of x by the definition of P. Indeed, they are maximal ideals generated by P inside of the polynomial ring K of x. And by first isomorphism theorem, since phi is onto, we get an isomorphism of the residue class field and the quotient field Q of x over P of x. And moreover, thanks to this isomorphism, we know that the degree of the residue class field over K is finite, and which is defined as degree P. And from the field theory review, we know that since P of x is irreducible, this extension degree is P of x. And in this case, thanks to this isomorphism, we can also conclude that degree of the given place, which is determined by the P of x, indeed the degree of this monic irreducible polynomial. And now the question, okay, we get an intuition about the residue class field, but how does the residue class map look like? And to understand these spatial maps, we will consider the rational function fields. We will explain it over rational function fields. So recall that residue class map is defined from the function field f to the residue class field zp for given place as evaluation z of evaluation of z at p if z in op, otherwise we set the image as infinity. And our claim is that if you consider a rational place, or in other words, it is generated by a linear polynomial, x minus a here, a in k. Let me write it as x minus a. And our claim is that the residue class map will look like the point evaluation in the sense we considered as motivation. This is OP, this is OP. What I want to say, first, let me define set of A is f of A over G of A if the denominator, the evaluation of G at A, the point A, is non-zero. We define it, the evaluation of the each polynomial. And if the denominator is zero, we set the infinity. And our claim is that for a rational place Px minus A, its residue class map can be viewed as evaluation of functions at given point in the base field K. And in order to see that, let me write a function as f over g. Here f and g are relatively prime. And first we want to see that if z in not in OP with respect to this place, determined by this place, that means x minus A divides g of x, because by the definition of the OP, we have the fractions f over p, and denominator is not divisible by x minus a. So if z is not in OP, x minus a divides g of x. Or in other words, that means g of a is equal to 0, and by the definition of z of a, this is infinity, and by the definition of the residue class field, this is also infinity, and we get the equality. And similarly, we also want to see that the equality holds when z in OP and to see that, let me write zp as f of xp or g of xp. So the evaluation of f and g at p. And our first claim is that f of x of p, the evaluation of f of x at p is equal to f, and similarly evaluation of g of x at p is g of a, then we will see that this is indeed can be seen as z of a. So let me show this first equality. We want to see that f of x of P is equal to f of A. Here, recall that P is the place generated by x minus A. And here first, let me observe that the polynomial f of x minus f of A is divisible by x minus A because it contains A as a root. If we plug in A in this equation, we get 0. And since it is divisible by x minus A, this shows that in this polynomial is in the given place Px minus A. As we consider its image under the residue class field, so that means if you consider the evaluation of f of x minus f of A at P, here note that f of A is constant, so in K it has trivial intersection by P, so it cannot be in P. So under the residue class map, its value is not going to change. And this is the 0 of the residue class field. And this shows us f of x of P is equal to f of A. And similarly, replacing f of x by g of x, you can also observe that evaluation of g of x is equal to g of A. And for the rational places, we understand that its residue class map is given in this form, or with this partial function. And in the next video, we will also do the same observations for the second example we consider for the place O infinitum. So see you in the next video. Bye-bye.